Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. I'm going to talk about another usage of application of trigonometry. Let us look at this problem. It says in a rhombus PQRS, the length of each side is 20 centimeter and the angle P is 60 degree. Here is the rhombus PQRS. The length I have shown PQ of 20 centimeter, but for rhombus all the sides are equal, therefore everywhere it will be 20 centimeter, all the sides 20 centimeter. And this angle P, this total angle is 60 degree. Question is, what are the lengths of its diagonals PR and QS? We have to find the length of diagonals. Now we will use property of rhombus and then apply the concept of trigonometry to solve this problem. So in a rhombus, we know that diagonals bisect each other at right angles. And the second property of rhombus is that diagonals also bisect the angles of the rhombus. So let's look at this first property. The diagonals bisect each other at right angles. It means PR and QS bisect each other, they cut at O. So OP will be equal to OR. Likewise, OQ will be equal to OS because diagonals have bisected each other. Also, they bisect at 90 degree. So it means this angle is 90 degree. Okay. Now, the second property of the rhombus which we are going to use is diagonals bisect the angles of the rhombus. So, for example, this PR will bisect this total angle P. So, if this total is 60 degree, this angle will be equal to 30 degree. Right? So, with the usage of these two, let us try finding out how we can now apply the concepts of trigonometry and we can find out the lengths of diagonals. Okay. Let us concentrate on the triangle OPQ. OPQ. In triangle OPQ, first thing, because this angle POQ is 90 degree, therefore this is a right angled triangle. Okay, and therefore we can apply the concepts of trigonometry. Now because this is 90 degrees, so this has to be hypotenuse. This is 30 degrees, so this will be the perpendicular and this will be the base, right? So if we use sine 30 degree, that will be equal to perpendicular by hypotenuse, that is OQ, which is perpendicular, divided by hypotenuse, which is PQ. So OQ by 20, we can write sine 30. Now we know that sine 30 is equal to half. So OQ by 20, we can write half equal to OQ by 20, and therefore we can write OQ, which is equal to 20 by 2, which is equal to 10 centimeter. Now we know that OQ is half of this total diagonal QS. Therefore, we can write QS, which is equal to 2 times OQ, and therefore 2 multiplied by 10, which is equal to 20 centimeter. So the first diagonal QS we found, that is equal to 20 centimeter. Now let's find the second diagonal. To find the second diagonal, we should use the relationship of cos 30. Because cos 30 is base, in this case base will be OP divided by the hypotenuse, which is PQ. Now we know that cos 30 is equal to root 3 by 2. So we can write root 3 by 2 will be equal to OP divided by 20. And from that, I can write OP is equal to 20 root 3 divided by 2. So OP will be equal to 10 root 3 centimeter. Because the diagonal PR is 2 times of OP, because OP was equal to OR, therefore PR is 2 times of OP. Therefore, 2 multiplied by 10 root 3 centimeter, which is equal to 20 root 3 centimeter. So this is another diagonal PR, which is 20 root 3 centimeter. The first diagonal QS was 20 centimeter. So with this example, you might have clearly understood how the concepts of trigonometry can be applied in solving some of the problems of geometry also. Thank you.